Next, we'll look at here a origin destination cost matrix. An origin destination cost matrix does the same thing as the closest facility model, but has different terminology. To start with, I'm going to bring in my physicians again into a new map here. Click OK to that, and I'll also bring in the hospitals. And yes, I need to bring in my driving data set as well. My network driving ND. There we go. Then I'll click on network analysis and choose the origin destination cost matrix. The difference between this and closest facility analysis is the terminology, and also that this is much quicker and is meant usually to find when you want to find more than just the closest. Often you want to find the distance or time it takes to get to all facilities from each physician location, for example. So the origin destination cost matrix is going to compute faster because it doesn't compute driving directions, nor does it compute or return geometries that are along the actual network paths. The only geometry it'll return are the straight line versions. But again, it's always computing the network impedance, minimizing that to get to the destinations. Visually, it just doesn't compute the more complex geometries as output for a map. And that makes it faster than using the closest facility model. We also have different terminology here. Instead of facility and incident, we have origins and destinations. Destinations are the same as facilities. I'll just type that in there so you can see the difference. So destinations are facilities and origins are the same as incidents, like so. So the first thing I'll load are my facilities here called destinations. So I'll click on the OD cost matrix layer, and then up comes the OD cost matrix tab, and I'll import my destinations or facilities, and that will be the hospitals. Again, I want to have the name carried over, and I'll put 200 meters for hospitals, which seem to work fine for hospitals. Snap to network, 5 meters offset. And I can put a sort field here also of the hospital name. And I'll click run. So that loads. Then I'll click on import origins. The origins are the physician locations, so origin to destination. So origins are the physician locations, the clinic locations. So I'll input those locations as physicians. And I'll use the name as the physician ID. The search tolerance I'll keep at 800 meters, which we found out is necessary to include all of those physician offices along the network. And I'll say snap to network and run. And all looks good. And I would of course validate that looking at the tables and stuff usually, but I won't for this example, but that's something you should do. Now I can look at my origin destination cost matrix tab, and notice there's not a lot of options here. There's mode custom cutoff, and then we can choose the attribute minutes, which is a cost to minimize, and the number of destinations. We'll just leave it blank, and that means all destinations. So it will find the time to travel to each of the hospitals for each physician and add those in the table. And the output here, straight lines, no lines. That makes everything much quicker. Since if we were to put lines here, it would just be a jumble of lines. We wouldn't be able to actually understand anything visually because we'd have 8 lines emanating from each of the origins to each of the destinations. So no lines, it computes quickly. So I'll click run. It's finished. And the results are in the lines output layer right here. So I can click on that and say open attribute table, even though there are no actual lines. It's still called lines. The attribute table then has the name field. And for example, here we see physician 1. And for physician 1, it says Royal Ottawa, 1 University of Ottawa Heart Institute, 1 Civic Hospital, 1 Riverside Campus, Sisters Charity, Children's Hospital, General Montfort. So all those 8 records or rows are all for the first physician. And then it tells us the total minutes in ascending order for that physician to get to each of these hospitals. And we can see that the first one, obviously, the Royal Ottawa, is the closest in terms of time with 6.7 minutes. And then the next one is the Heart Institute, 7.49 minutes, etc. The disadvantage of doing it this way, of course, is that we don't have that visual analysis to figure out if we want to reduce the number of destinations or facilities like we did with the first one. And we also have for 2, physician number 2 then also has 8 records. So each physician here has 8 records and the time in ascending order. And that's called the origin destination cost matrix. And it's a matrix here, but it's flattened to one row in the total matrix, in the total minutes column here. And that's all there is to the origin destination cost matrix. We could have just done one if we wanted to, one destination, and that would be equivalent to what we did previously with the incident facility model. And we can see here that each physician now has only one record. So for example, physician 43, closest to Sisters of Charity Hospital, and it's almost next door, basically. Pretty much on the same location. Probably one of the offices right in the building or something. It's less than, it's a couple seconds at most. So that's origin destination cost matrix. And again, it's faster, but doesn't provide driving directions or actual network lines of travel. But it's all based on calculating time back to the destination along the network, using the network impedance value and minimizing that for each location. So in other words, each of the results is the fastest way, more or less, to get to the hospital for each physician, for each hospital.